Well, good afternoon, everybody, and happy Thursday. Welcome to Simulation Month. Yeah, I think I'm going to deem October as Simulation Month because today we're going to be talking about Creo ANSYS simulation tools, or ANSYS simulation tools for Creo. And I believe next week or last week we talked about Creo Simulate Advanced. And next week we will have a webinar on Creo Flow. So pretty exciting stuff. And the whole idea between these simulation tools is to give something into the hands of the design and engineering team so that they can make decisions earlier, so that when these models, your designs, go downstream, they don't come back for a massive amount of rework. Like rework would be minimal, if any. So the whole idea is to shorten the product development cycle and prevent delays, and to basically design for function. So my name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI, and running the presentation and overview today for Creo ANSYS Simulation Tools is Emily Pinto, who is an applications engineer with the PTC Virtual Center of Excellence. So without any further ado, Emily, we can see your screen and you can take the presentation in your hands.
Perfect, thank you.
You're welcome. Thanks for helping us today.
Yeah, not a problem. So analysis is one of my favorite topics to talk about, but I'll try to keep it brief and useful today. So as we know, ANSYS is a really respected name in the industry. They have a really great reputation for all of their different analysis software. And we've partnered with them to bring ANSYS into Creo, because the most useful thing is when you have analysis results while you're still making design decisions and trying to figure out what's good to do, what's not good to do, where you might have issues. So as easily as we can bring those two worlds together, that's what we want to provide for our customers. So I do have a demonstration to show you today, but we'll talk about some briefly talk about some challenges and capabilities, just to make sure we hit all of the points for when you might want to use this and what value it might bring to you. Can you see my screen? It's oh, okay.
Yes, Creo ANSYS simulation. I see your screen.
Perfect.
See the presentation
slides.
Cool.
Awesome. Okay, so understanding product performance is really key to creating a good product the first time around and shortening those design cycles. Analysis has always been seen as something that experts do, because it's traditionally been very complicated and required a lot of skill and expertise. But that's a challenge previously to bringing analysis earlier into the design process. But without using it while you're building your product, you end up tacking analysis onto the end, which then requires, of course, you're going to find some kind of an issue. You're not designing out of the box enough if you nailed it on the first try. I don't know, but certainly you can expect some problems. So that just increases your design cycle time. Talking about Creo ANSYS solutions in Creo, we have two: Creo Simulation Live and Creo ANSYS Simulation. Creo Simulation Live is a separate product from the one that we're talking about today, but it works hand in hand with Creo ANSYS Simulation. Both are powered by ANSYS, but they're different uses, right? So Creo Simulation Live is really for exploration, design exploration, trying to figure out what are all the possibilities and directions you could take something, while having analysis results, ready at your fingertips to see very quickly what's going on. Creo ANSYS simulation is the more traditional ANSYS engine that we brought into Creo. And so that's going to have those really high fidelity results, give you all the capabilities for setting your analysis up in a way that really reflects the situation that you need to account for, right? So you can really see all those stresses and a true to life representation of what might happen to your product in that scenario. So, covering the basics here, it's a comprehensive simulation and analysis. We have structural, thermal, modal. It's a very fast simulation modeling and setup. So we've really focused on making the user interface flow from Creo. So if you're familiar with Creo, you're going to be able to use this ANSYS simulation tool. And we've tried to make it as easy as possible and straightforward as possible for the engineer, right? The way that the engineer typically works, and software that the engineer is used to using. That's what we aimed for the user interface for setting up these simulations. And in addition, ANSYS has really great technology for automatic meshing and contact handling, which takes a lot of the, previously, back in the day when you had to do that manually to get, a good analysis result, that was where a lot of that expertise came in. But now the automatic meshing from ANSYS is really great. So you can have it do all of that technical stuff for you and just spit out those results. So high fidelity and accuracy of the results. It's extremely reliable, high fidelity software. The results are visual and interactive, so you can really interrogate what's going on and understand what those results mean. So it's not too difficult to understand what those results are telling you. And then it's a true integration of Creo and ANSYS. So you're going to be in the same environment, just moving back and forth between tabs, which makes it super easy. Okay, so then let's switch over to the demonstration. Just give me 1 second here. Okay. So this is our Creo user interface. So it might look familiar. To work on something, it's the same way you're going to set anything up. The ANSYS files aren't new files. It's just like adding colors or materials to your model. You're going to add the simulation definition. And in your applications tab, there's a button here for ANSYS simulation. All that does is it launches some new toolbars for you. You have your simulation tree over here. As you can see for the demo, right, we already have some of these set up. So this is true if you set up an ANSYS simulation on your model once. Anytime you open that and you go into the ANSYS simulation toolbar, you're going to see all of the simulations that you already have set up, from previous Creo sessions. So they're all saved over here. Loads and constraints, right? Pretty straightforward. You have your forces, constraints. Maybe you have a displacement, so you're fixing something. The way that it looks to add those, you're going to have your choice. You have fixed displacements, fixed, you have displacement, you have support constraints. So maybe you want to define something as a planar constraint or a cylindrical constraint, ball, frictionless, all options. The user interface, again, super straightforward. It's just asking you for the cylindrical constraint, what surfaces you want to apply it to, and then it gives you those little arrows so that you know that's fixed now, of course, cylindrically. Now, the refined model, this is where you can really take advantage of a lot of the power of ANSYS in terms of everything that you can set up. So you don't need to refine the model. You can use a lot of the automated meshing, but you do have idealizations for mass, spring, shell, beam, can really speed up and increase the accuracy in certain scenarios. So for contact, you can do an automatic contact detection, or you can do it yourself. For the mesh settings, this is where, right, if you want to just choose your resolution, great, run a low resolution, find any trouble spots, zoom into higher resolution if you want. You can also set your global mesh setting. So for your whole model, this global setting is going to say, all right, what's my minimum, my maximum? And you do get used to what you would use there, but you can always start off with just some generic mesh sizes or a mesh resolution, and then we'll see how the refining process goes on from there. We'll see that in a minute. Takes a second. Mesh is complete. Lets you know that there wasn't any issue. 100% ready to go. If you want to see what that looks like, you can see it here. So it does do some refining in certain areas with higher changes in geometry, things like that. The simulation then is very easy. Once you have your loads and your constraints set, which we're just using those 2 force loads that were already set up, you just run it and it'll go through and tell you where in that process it is to solve. So again, very quick compared to maybe analysis back in the day. I know that even just in the past couple of years, things have definitely been sped up. And, this is a relatively simple model, but you can do all sorts of complexity in here, right? The more complex your model is, or the more refined you have your mesh, the smaller those sizes are, the longer it's going to take. But as you can see, right, even with the high resolution on this part, right, it took a couple of seconds, less than a minute. So your results are ready to go. It automatically gives you the most commonly viewed results. So those are going to be your von Mises stress. You can interpret that from the legend. If you want to view the maximum stress, this is actually a little highlighted circle. So this red circle shows you where your maximum stress is on the model. So that's really nice. You can also see, your minimums as well. You just have to look around for that. Now you can see the other side. It's a little bit different geometry. If you want to see what if you want to see what the results are at any point, like for instance, right now we're viewing the von Mises stress. So you can click around on your model and it'll show you the von Mises stress at that point, right? So right here, it's about 71. Now, if you don't want to keep clicking around, if you want to know the stress or displacement or whatever result you're looking at a certain point or on a certain surface, without having to keep clicking on it, you just want to see it all the time, you can set up these little simulation probes. And as you add results, so for example, this little probe is a new result, it doesn't have to rerun the analysis or anything. It'll just recalculate for what it is that you want to see. So you have your probes down here. You can show them all, you can hide them, you can delete them, right, add new ones. They're managed just like that. As you want to see different items, you can choose different types of results to define. So for your displacement, maybe you want to see a contour plot, and you can see as you've added these more advanced results, it didn't calculate those right off the bat, but again, you don't have to rerun the analysis. As you add results that you want to see, you just update them, and those little clocks will tell you that those haven't been calculated since the latest analysis was run. So this is the contour plot for the displacement. So again, you can do lots of different interactive things with it, like animations, so you can see. A great way to use the animation is not only to understand how it's bending and moving when you see those red zones or those yellow zones, but also, did you apply your constraints correctly? I always like to mention that because that definitely changed my life when I was not sure if I set the model up right. I was like, oh, this is so smart. So once you know where maybe your highest spots are, you have high stress, high displacement, whatever it is that you're looking at, and you want to make sure that your results are as accurate as possible, that's when you can go in and maybe do a local mesh refinement. So you don't have to put small elements, just if you want high accuracy results in one area, more refined, more calculations per surface area, you don't have to do it to the whole model. You can just run one, see where those high areas of interest are, and then rerun it with a smaller mesh in that area. So again, just some little tips. So that shouldn't change your results too much. Again, you're just doing more calculations in those sections. You can see how small those elements are there. So you don't want to do that maybe to your whole model because it'll take much longer to run that analysis. And you don't have to change anything else, right? Once you rerun that, rerun the mesh, the rest of your analysis is still here, so you can just rerun it, and now it'll do all those calculations for each of those mesh elements in the refined area. So it just takes a second there. Took about 15 seconds, right? And the nice part about this is that we're doing a little analysis session here, but you can imagine if you run that first analysis, and you want to make a change to the geometry, see how it affects it, or if you can improve it, that's always a good way to do it too. You don't need your absolute 100% most precise results your first time through necessarily if you want to try to make improvements for any problem areas. You can see here now it's up to about 91 for the von Mises stress, 91 megapascals. Your probe here also went up, so that area of stress went up a little bit. And so you get a really a nice, a really nice understanding of what's going on. So now if you do have any, really crazy analysis scenarios that you still need to send your analysis out for, whatever it might be, at least, you have your model to a really good point. It's not going to fail. That your stresses are under control, that you've made some good design decisions to, sidestep any issues that might have been in your original design your first time through, and now you're doing it here. So it's so much faster and so much easier. Those iterations are going to be, the iterations are really going to decrease in time. So switching over, right, this is a really great tool, but when do you need it, and what can it, what really can it bring business value wise? So a deeper integration of simulation means you're using it more often, which means you understand the performance of your model while you're still building it in CAD more often, which is always a good thing. It's an improvement of quality. It allows you to do some more daring or innovative ideas, because you don't have the risk of trying an innovative idea and having to go through all these long design cycles to get it to a point where maybe you don't even want to use it, or it needs a lot of work to be finished. So having the analysis at your fingertips, and especially this really high accuracy analysis, allows you to try a lot of those things and improve your product as you go. Shorter development cycles. Every time you have to pass something over, it takes people a long time just to see an email, let alone if somebody else is running your analysis. It's going to take a long time. So not only, do you not have to send it over, but you can maybe do less improvements because you're the one who's looking at those results and making the geometry changes. All of this results in a quicker time to market, which is, always good and allows you to meet your business goals, your different project deadlines, things like that. So all in all, Creo ANSYS simulation helps you build a better product in the end, and it's all within Creo, so it's very easy to use and hopefully very useful in your tools that you have available to you in your parametric modeling environment. All right, Rob, I can pass it back over to you.
Absolutely. Yeah, the integration is a big deal because you don't have to export your model and put it into a separate software. And the other thing is we have an expert on our staff. His name is Bill Stickney, and he's a really smart guy. And he is really one of the foremost experts in finite element analysis and computational fluid dynamics in the country, not just on the East Coast. I mean, he's worked with projects with NASA regarding the vibration of rockets and the weightlessness pool that they use for training. He's worked with a lot of the national laboratories and some military institutions for our government on specific projects that we don't give a lot of detail on, that I don't even know the detail on. But he's a big proponent and supporter of these solutions, and Bill's not a guy who says, well, just because PTC has it available means that you should use it. He's looked at these tools and he understands that they add a tremendous amount of value because of what they do early in the design stage. And what we do for our customers is we're able to get them up and running and to become proficient on all their Creo tools, especially simulation, so that they can use them, so our customers can use these effectively. It's one thing to purchase a tool, it's another thing to have somebody who can become proficient at it to use it. And that's where we excel, because it doesn't make sense to buy a solution or invest in software if your team's not going to be able to use it and get the return on it. And that's where we come in as a value-added reseller, so that you could start experiencing the benefits and reducing your product development cycles by implementing simulation. And we can work with you also to determine what tools are going to work for you, because in a lot of cases that I've seen, people say that they want, say, Creo Simulate Live, or they want another type of analysis tool, and it's not the right one. So that's where we come in as experts, where we can guide you and help you and get your team proficient on it so that you can see a return on your investment rather quickly. So anyway, Emily, thank you very much for the presentation and the overview. If you have any questions, you can respond to the email that you received, the invitational email for this presentation. Those responses come directly to me. I will be uploading this recorded webinar to YouTube. That will be, and the email with the link will be sent out by tomorrow so that you can watch this again at your leisure. So be sure to join us next week for Creo Flow. That is absolutely a fantastic suite of CFD tools. And thanks for being on today, everybody, and have a great day. Emily, thank you again, and take care, everyone.